Hello everyone. In today's class, we are going to be comparing ionic and covalent compounds. Let's take the first example. Solids are regular lattice of particles. The pattern of arrangement in ionic compound is different from that of covalent compound. The particles in the lattice of ionic compounds are made up of ions, as the name implies, while the particles in covalent compounds are made up of molecules. Let's look at this particular example. Look at the lattice of sodium chloride. The ions are held in a regular lattice, just as you can see, and the force of attraction between the molecule is strong. Then look at the other hand, the lattice of ice. You can see the space between the molecules, so they are still arranged in a regular lattice, but the force of attraction between the molecule are weak. So we can now take a summary of this, looking at ionic and covalent compound. Both type of compounds, number one, have regular latticed structure, and then number two, both of them they form crystals. Now, having seen the similarities between covalent compound and ionic compound, let us see how they are different from one another. In ionic solid, the particles are charged and the force between them are strong. In molecular covalent solid, the particles are not charged and the force of attraction between them are weak. So let us look at the earlier example again. If you carefully look at the lattice of sodium chloride, you will discover that the lattice is made up of positive charges alternating negative charges, and the particles are compacted, showing that the force of attraction is very strong. Then look at the lattice of ice. You will discover that though the particles are arranged in a regular lattice, but you can see spaces between the particles, indicating that the force of attraction between them is weak. Now, having seen that particular example, I want us to go to another way by which we can differentiate an ionic bonding from covalent bonding. In ionic bonding, electrons are transferred from the metallic element to the non-metallic element, while in covalent bonding, the two non-metals that react together both need to gain electrons in order to form bonds to achieve a stable outer shell. So they are able to manage this by sharing electron with one another. Let us also look at two examples to back up this point. The first example you can see is the ionic bonding between magnesium atom and oxygen atom to form magnesium oxide. The magnesium atom transfers two electrons to the oxygen atom, and you discover that the oxygen received two electrons, and that is indicated on the compound by their charges. You see that magnesium is +2 and oxygen is -2, showing also that the compound is charged. Then look at our second example, the covalent bonding between two hydrogen atoms. You can see in this case that both hydrogen atoms receive electrons, and they now both become like helium. So it is important to note that there is always a transfer of electron in ionic bonding, and then there is a gain of electron in covalent bonding. And another thing we have just talked about is that the force of attraction between the ionic compound, between the particles of the ionic compound are strong, while the force of attraction between the covalent compound are weak. And then finally, we say that the ionic compound are charged while the covalent compound are not charged. Okay, in our next class, we are going to be talking about the properties of ionic compound. I will want you to click the subscribe button so that the moment the video is being uploaded, you will be able to get notifications. Thank you.